Welcome to Industries in Chemical Engineering, a series of short videos intended to expose sophomore chemical engineers to the variety of career options available within chemical engineering. I'm your host, Dr. Vijay Toko from the Department of Chemical Engineering at the University of Florida. Just a reminder, all information presented here comes from my own experiences, discussion with engineers in these fields, and my own curiosity. You should expect your experiences in these fields to vary considerably. This is Industries in Chemical Engineering. Episode 5, Food and Beverage. Some examples of companies you could work for in the food and beverage industry should be familiar to you from taking a trip to the grocery store. General Mills, Nabisco, Tropicana, Kellogg's, Kraft Heinz, Nestle, PepsiCo, and Hershey's, among many others. Let's start by considering the state beverage of Florida, orange juice. Without looking at the label, see how many of the ingredients you can name. If you're like me, you probably had assumed that it was oranges and water, maybe with a little bit of sugar added. But here's a question that had always stumped me. Oranges are in season in the coldest winter months in Florida, so how is it that you can buy orange juice in the middle of summer? Related to this idea, oranges are a bit like a mystery box. The good ones are sweet and delicious, but the bad ones are bitter and gross. Yet, store-bought OJ tastes pretty consistent. How do the manufacturers manage this? Let's try to look at the label. After water and juice, we have a whole bunch of vitamins and minerals, about half of which I can pronounce. Once again, a team of chemists, food scientists, and chemical engineers are responsible for the formulation, while a chemical engineer would take on the scale-up. Also in the beverage category, an invention that I think is brilliant are the powdered, or liquid in the case of Mio, drink mixes. After all, lemonade is mostly water anyway, which is heavy and expensive to transport in large quantities. Additionally, the consumer can choose their own dilution. Very helpful for those who think Gatorade is too sweet and syrupy, or not sweet enough. Try to imagine the process by which these drink mixes are manufactured. Regular lemonade usually has fresh squeezed lemons, so how do you get lemon flavor in solid form? Moving on, similar to toothpaste, several foods are in the gray area between solid and liquid. For example, peanut butter and mayonnaise. Remember that these need to be pumped to transport them around the plant and to fill the jars, so the material properties must be known. Switching gears again, let's talk about the process of making chocolate. If you ever have the opportunity, I strongly recommend that you visit Hershey Park in Hershey, Pennsylvania. One of the attractions involves a ride through a mock chocolate factory where they show you every step in the chocolate making process, from roasted and shelled cacao nibs to chocolate liquor to the final product. And yes, the famous singing cows are at the end of this ride. After visiting, I looked into the history of the Hershey Company and learned that one of the reasons why it became so successful was that the founder, Milton Hershey, was adamant about using fresh milk instead of powdered milk in the recipe. This is why the headquarters are located out near the dairy farms in Pennsylvania. One of my most embarrassing moments from my college career came during an internship interview with General Mills. I was asked what my favorite cereal was, and of course I answered Trix. The interviewer then asked me, "How do you think we make that?" And I was absolutely flabbergasted. I had never considered how they make Trix, or any cereal for that matter. I had nothing intelligent to say beyond that it starts with wheat and grain, and unfortunately I did not get the internship. Afterward, I was so fascinated that I looked up the process to make cereal and found that it can be easily explained with the principles of chemical engineering. In the 50s, General Mills invented and patented a device called the puffing gun, and it works by understanding the phase diagram for water. It starts with wet pellets of grain that are put into the sealed puffing gun and heated. As the temperature increases, the pressure increases as well, which we know from the ideal gas law. And some of the moisture is evaporating as well, which also increases the pressure. When the pressure gets very, very high, the vessel is opened rapidly, which instantly drops the pressure, and in turn all the moisture evaporates very quickly. The cereal pieces are puffed, kind of like popcorn. One question that I always had that I never got answered is how do they make the different shapes in Trix? Maybe you can look this up and teach me. Chemical engineers also make all of the brand name snack foods. Ever since I was little, I wondered what was actually in the seasoning for Flamin' Hot Cheetos and Cool Ranch Doritos. Both snacks have such a unique flavor profile. Recently, Lay's Poppables and Tostitos Scoops have been released, which are both notable for their shapes. This is another question for which I don't have the answer, but I'm absolutely dying to know how they make hollow potato chips and bowl-shaped tortilla chips. By the way, these products are all brands of Frito-Lay, which is a subsidiary of PepsiCo, who hires plenty of UF chemical engineers each year. If you go for an interview with them, You may want to prepare for the "how do you think we make this?" question, so that you can be more prepared than I was with General Mills. To conclude this video, I have some recommended viewing of clips of how it's made, which are all freely available on YouTube by searching these terms. As you watch, appreciate the scale at which these products are made, and appreciate that one day you might be designing or operating one of these processes. That's all for this episode. Thanks for watching.